having losing this money. So now we will look at the last case scenario where we have an application performance issue. So an issue has been reported at 8 in the morning. A specific tried to work on it for 2.5 hours at 10:30, and after 1 hour, so create a SWOT with a team with different teams, and like at noon, collection of information on multiple devices and tools. So it's like you can clearly see here the traditional way that it's taking much more time to identify the issue. So far, issue has not yet been identified. So we are already at 4 hours. So now what happens? So with the traditional way, so what application we use is FTP, SFTP, and SLOOKUP, PuTTY, and what happened next? So collected information with SMEs from different teams at 2 in the evening, and at 2:30 the issue has been identified, and it's only at 3 in the afternoon. So the fix has been applied. So the whole summary here, what you can see in this timeline, is the impact to the business was 7 hours downtime, and we have a cost and a loss of 2.1 million to the business, which is very critical. So with the Nexus dashboard, product vision, dashboard inside product vision, we have auto remedy operations across 7 layers of hybrid environment, which are fully observable network, where operators can identify issues quickly, auto suggest solutions, operators fixes the issue quickly, and we have autonomous operations. Operators focus on long-term objectives. So now what you can see, imagine you're a network administrator of a retail company and you receive a report about application performance issue. One view helps you to have a single view of all sites for REST scopes. So actually what you are seeing, we are on the map view. So let's change table view. So the table view, so what you can see here is we have a critical anomaly score. So the critical anomaly score will indicate you where the issue is. But in order to have those information, let's switch back to map view. Once we are on the map view, let's click on the red dot here. So the anomaly score indicates you is critical. Once we click on critical, the application teams report what we can see, the application teams report a problem on the host 10.110.1.34. So we need to go to the flows sections to investigate. Insight has the capability to review the telemetry for troubleshooting. So here we have a summary of everything here. So let's click on flows. So once we click on flows, so now we want to know if there is some dropping packages on the host 10.110.1.34 port TCP 8080. We use flow telemetry to correlate data over time to the given end-to-end path and latency. So let's apply the filters. Like we mentioned, the source address is 10.1.110.1.34 and the destination port is 8080 and the protocol is TCP. So now what you can see, we can detect an increase in packet drops. Insight shows a real-time series-based packet drop statistics, indicating exactly when and why this happens. Scroll down. So what we detect here is the host 1.110.1.34 is connected at port 1/24 only for one. So what we need to do now, we need to analyze this flow. Let's click on it. Once we are here, so in the flow details, what we can see, we can observe that this host is on APG code services. The packet drops indicator is high and more. Now we would like to have more details on it. So like what we have said earlier, so this is a node and the port, the interfaces. So let's go and see more details about it, and even here you will have the packet drops. Inside it gets some policing drops. So now we want inside to suggest how to fix it. So next, let's go to anomalies and do deeper investigations. So we are looking for policing anomaly, but with that we can identify different types of anomalies like flow events, interfaces, routing protocols such as CSRs, errors, violations, to be compliance requirements, endpoints duplicating or more. So once we have added policing in our filter, we can find this specific information. So what we can see now, the policing event is active. Let's have more details about it. Once we go to the policing, so what we can notice now, using the analyze screen, so what we can see is a common question. So what happens? Packet drop detected due to policing. Once the problem began, so the description of what happened here, and when the program has begun. So the program has begun at 12:05. So what we can see here, and is continuing. Who is affected? So here we can see the affected node or the affected object. As we already know, the IP is 10.110.1.34. And even more, how to have this fixed. So we have recommendations here. With the Nexus dashboard, we provide you the recommendations. So inside suggest reviewing the quality of service policing on the code services APG. So now what we need to do, we need to go to ACI console and remove the QoS policing that is dropping the packages. So here you can see that using the Nexus dashboard, so we have been able to identify the issue quicker. So instead of having a whole day downtime, so 20 minutes has been taken to identify configuration mistakes and recommended solutions. The Nexus dashboard has delivered real-time insight assurance and applies baselining to identify root cause. So now, once the fix has been already been applied, let's go and have a look at it. You can see from here itself the station is cleared, and even here we can see that the time which has been cleared. So Insight helps you to check the durations of the fault, affected objects, and who modifies the QoS policy. Use the code services APG. Scroll down. So what we can see here now, in Analyze screen, we can review the logs of the devices, and now we will see when the admin creates and removes the acquired QoS policy or SDPP-POL. So all those information, we will have it here on the Analyze dashboard. Thank you.